Hello everyone and welcome to Java Basics. Before we integrate Thymeleaf into our project, we need to do some cleanup of the code through refactoring. We can then tie this all together through Thymeleaf to create a simple UI. Along the way, we will deepen our HTML knowledge, touch CSS, understand layered applications, and many other subjects. But in this video, we need to explain some big concepts first on our road to that goal. Don't fret, we'll be back in Thymeleaf in the next video. But first, we need to understand some deep concepts. The code from last time can be found here. You can see it in the description for the video as well. The code we work on today is available here. It is in the description too. Don't forget to start and follow me on GitHub while you're there, and here too while you're at it. We showed some refactoring before. This means moving code around in our project so it will make more sense in a new position. In the current project, we have a web service that implements a Wordle guest call. This is great. We want to keep that. But I also want to add a web-based interface that also implements Wordle. This is a problem because the code in Wordle WS would be very similar to the code in Wordle MVC. Now, I could copy and paste the code from Wordle WS to the new MVC class. But if I do that and I need to change something in the code, I'll need to change it twice. This makes things far harder and it obviously never ends. Once you start copying code around, it forms a mess. What if we take the code from the Wordle WS and move it to a third class, which we would call Wordle Service? This class will include the common features of Wordle WS and Wordle MVC, which we can then reuse so there won't be duplicate code in the web layer. This represents two important ideas in programming. The first principle is the don't repeat yourself principle, also known as the DRY principle. It essentially means don't copy and paste. Don't make code that even remotely looks like copy and paste. Write code once and try to develop it in a way that will encourage reuse of the code. Like any guideline, this can be taken to the extreme and is a hard idea to follow when beginning. The best way to learn it is through trial and error. The second principle is the layered architecture. We may break the application into layers based on roles. A presentation layer might be responsible for the user interface. A business service or service layer can be responsible for the logic of the application. Finally, a database layer might be responsible for storing information. There are other ways to divide an application, but it's important to understand this common approach. This is a bit theoretical for this stage, though. Let's go to the code. We need to start by creating a package to store our new code. We'll call the package service and create a new class in that package, Wordle Service. Putting this class in a separate package helps us keep the code separate. It doesn't matter much with one class, but when we have dozens of classes, this helps a lot. We add the service annotation. This is called a stereotype in Spring. There are 4 standard stereotype annotations in Spring: component, repository, service, and controller. Notice that this list is missing annotations such as REST controller, and that is because it is an alias for controller. We pick the right stereotype based on the specific requirements of a class. A service is a general business object. A component is something that we can reuse. A controller serves as a gateway for user actions, and a repository handles data storage or retrieval. Let's start filling in the service. we can start by taking the code at the top of the Wordle web service and just moving it as is to the service. The code at the top is generic, the word, the dictionary, etc. But the methods themselves won't be the same. We'll need to think about them further. The first method needs to validate that we have a good word. We can call it that and return a string with the error message, if applicable. If the word is valid, we can return null. I could throw an exception here, but this isn't a real error, so most developers won't consider that, would consider that bad form. The top portion of the guess method performs validation and returns error message strings. We can just take the code from there and use it to implement the validate method. Once we paste it in the validate method, the compiler kindly shows us that we're supposed to return a string, not a result object. So we remove the code to create a result object, which solves that problem. If the word is good, we just return null on the last line of the method. Next, we need to invoke the Wordle service to validate the code instead of the code that was originally here. We invoke the method, then if it isn't null, we return the error, same as it was before. But there's one problem. We don't have the Wordle service. I can just do a new Wordle service, but that's not how String works. String needs to inject the values for the objects. One of the big concepts we need to understand to work with String is inversion of control. To understand it, let's look at this typical Java code that one would write daily. There's nothing wrong with this code. It's good code. However, it limits your ability to do things. One of the big values in object-oriented programming is the ability to inherit and extend. These are big features I haven't discussed yet, but for now, we can say that an object can be enhanced in various ways. We might want to extend my helper and verify that the call to my API is indeed triggered a call to do something. That is a legitimate need. We might want to enhance the call in some ways too. And to test that, the user has permission to invoke do something. We can do something like this. That code will create a different object instance based on a situation. But then we need to code all the logic of which instance would be returned in every situation. In that method, the createMyHelper method would need to have a lot of statements to determine how to create my helper. IOC is about removing that noise. We normally control the exact object that will be assigned. With IOC, we invert that control, and the framework, in our case String, takes over. It will decide the object to assign here. This code will work as the previous code did in String. String will make sure the field has the value you expect. You don't need to allocate my class or my helper for that matter. It will have the right value in place and you don't need to do anything. With IOC, we can break down the complex system into individual separate components, also known as beans, that interact with one another through well-defined interfaces. They can be replaced dynamically as we need. But there's one more thing you will notice, that this is very verbose. We need to write this constructor just to pass the parameter, annoying. The Lombok library, which we added initially, includes the ability to define a constructor automatically. we can use the all-args constructor or all-required-args constructor to create a constructor automatically for the final fields in this class. That means that if we inject more beans, it will save us the work of adding them to the constructor and reduce boilerplate. Going back to the code, we can now inject the Wordle service into the Wordle WS class. We define the field as a private final field and add the all-args constructor annotation, which will add an implicit constructor that Spring will use when constructing this class. It will automatically pass in the Wordle service instance, and we will have a binding between the classes. Once this is done, the Wordle service code is valid. Going back to the service class, we can add a new method, the calculateResults method, which returns the results of the given guess. The method returns the character result array since I assume validate was called before. Notice that this is internal code, so we can make more assumptions than normal. We also need to import the character result class, which is missing here. Implementing this method is simple. We select the existing code, copy the whole thing unchanged into the new method. This just works with no problem. The one line of code we need to write here is the return value. We return the result when we're done with this. Finally, we can now invoke the same service method to return the result object we used for the web service. This means the server code delegates all of its heavy lifting to the service class, and the Wordle WS class can now focus on the important things for it, such as generating better JSON. This is half the job, since the value in this code will become apparent as we implement the MVC class. In the next video, we finally adapt the code to work with Thymeleaf so we can have a rudimentary web UI. If you have any questions, please use the comment section. Thank you.